All right, let's look at an example of how to find the probability of something using our sampling distribution of the sample mean. We're going to follow the same steps we would if we were looking at the population with a normal distribution, because once we've verified the central limit theorem, we know that we have something that is normally distributed. And so the process stays the same. The only thing that's going to be different is the z-score equation. So the example we're going to look at says the federal Pell Grant program provides grants to low-income undergraduate and graduate students. In the 2007-2008 academic year, the Department of Education reported that the mean grant amount awarded was $2,600 with a standard deviation of $500. Use this information to find the probability that a random sample of 36 recipients would have received more than $2,940. So looking at our important information, the mean grant amount awarded, for some reason my pen is not connected. There we go. What the mean grant amount awarded was $2,600. The standard deviation was $500. We have a random sample of 36 recipients, more than $2,940. And we're going to find the probability. So I'm going to start this problem by coming off to the side and writing down mu, sigma, x bar, and n. So the mu is the mean amount awarded, 2,600. Sigma is the 500 for the standard deviation. X bar is the 2,940, the amount that the random sample would have received more than. And then N is our 36 recipients. So this just helps me kind of organize all of the numbers that I've been given. So the first thing we're going to do, we're being asked to find a probability. My sample size is greater than 30, so I know that it's normally distributed. So I'm going to find the z-score. And as a reminder, the z-score equation for the sampling distribution of x bar is x bar minus mu divided by the standard deviation divided by the square root of n. And because I wrote everything out on the side, I don't have to try and figure out where everything goes. I'm just plugging the information in. So x bar is 2,940, mu is 2,600 divided by 500 divided by the square root of 36. When I go to do this in my calculator, if I do the top piece in parentheses and I put the bottom piece in parentheses, I can type this all in one, so long as I have those parentheses around the top and the bottom. And when I do that with the parentheses, I get exactly 4.08. There is no rounding on that. It is exactly 4.08. So now the rest of this process is exactly the same as it would have been if I was looking at an individual. So step 2 is to draw the curve. Now you get to see my curve drawing skills. Hey, that was really good. There's my curve. And then we're going to label 4.08. So if we picture our curves from before we would have 1, 2, 3. So we got to keep going out a little bit further. 4. Here's 4.08. And then it says more than, so that's shaded to the right. Very small amount of area, but there is still a little bit of area there. And that was step 3, completing my shading. And then lastly, we go to step 4, which is to use Excel or another type of technology. In Excel, we're going to do norm.s.dist. Oh, actually, this is more than, so we got to do 1 minus norm.s.dist. 4.08, comma, true. And our answer turns out to be 0.00002. Very small probability that the 36 recipients would have an average of $2,940 or more in their Pell Grants. But that is how we use this new sampling distribution and the z-score to calculate probability.